Hi, good morning everybody. How are you? I want to talk to you about penicillin today. First though, don't forget, if you click on the link in the About section below here, you can find the script for this talk, and you can find some questions, and you can find sample answers and things like that. Have a look. If you like this, subscribe, like, all that kind of stuff. Okay, so penicillin. What is penicillin? Well, basically, penicillin is an antibiotic. It's one of the group of antibiotics. And what do antibiotics do? Well, they kill bacteria, basically. So to talk about penicillin, of course, we have to start by talking about bacteria. What are bacteria? Bacteria, of course, are single-celled organisms. Bacteria are generally a few micrometers long, which I cannot do with my fingers, of course, because that's tiny. You cannot see them with the naked eye. There are quintillions of bacteria in the world. You have about 39 trillion bacteria inside your own body, and they live in your stomach, most of them. What they do is they help break down the food that you eat. Without those bacteria breaking down the food in your stomach, you couldn't process all of the food. You would have to pass it pretty much solid, and you wouldn't be able to extract the nutrients and the sugars and all the good things from those foods. So we need bacteria. Of course, there are bacteria outside. 1 gram of soil apparently has about 40 million bacteria in it. And without those bacteria, anything that died, plants or animals, would just lie there on the ground. We need those bacteria, again, to break down the things that die into their component parts, so they can be eaten or absorbed or released back into the atmosphere as nitrogen. So we need bacteria. Without bacteria, we couldn't survive. We couldn't have life as we know it today. And there are good and bad bacteria, of course. Actually, no, there are not good and bad bacteria, because that implies that bacteria have intentions, which of course they don't. There are bacteria that are useful to us, and there are bacteria that are harmful to us. That's probably a better way of putting it. Bacteria, of course, replicate themselves. They replicate using a process called binary fission. Basically, they reproduce their DNA, and then they split into a new cell, reform their cell walls, and you have 2 bacteria. And again, those 2 bacteria can reproduce, and they can reproduce exponentially. So 2, 4, 8, 16, 32, 64, and so on. In perfect conditions, a bacterium can reproduce itself every 9.8 minutes. So if you think about that, you can imagine how quickly they can reproduce. Some bacteria that are harmful to us, bacteria that destroy tissue, like after a wound, if you get an infection. Bacteria, because they reproduce, they can become too numerous. They can overwhelm parts of your body. Bacteria also produce toxins as well, when they're alive and when they're dead. Those can also be harmful to us. As a slight aside, some people like to think that life on Earth could have begun with bacteria. Life on Earth could have begun with bacteria that traveled on a meteorite from a different planet, from even a different universe. Bacteria are some of the hardiest creatures, living organisms on Earth. You have bacteria in extreme cold, extreme hot. At the bottom of the sea, some of the hot vents down there, we have extremophiles, bacteria that live in those hot conditions. So some people think that bacteria could have survived an interstellar journey, and life on Earth could have actually begun with bacteria from a different universe, from a different world, which is a nice way of thinking about it. We are all aliens. So if you get a bacterial infection, say for example food poisoning or an infected wound, what happens? Well, your body has to kill the bacteria. How does it do that? Your body produces white blood cells. There are different kinds of white blood cells, but the kind that kill bacteria, there are 2 sorts. One of them hunts down the bacteria and puts a protein marker on it. So they find the bacteria and they put protein markers on them. And the second type of white blood cell, they follow those protein markers. They basically hunt down the bacteria and they kill them. They surround them and they basically eat them. Okay. Now, obviously, if you have a very severe bacterial infection, if you have a lot of bacteria, the white blood cells cannot eat all of those bacteria, and you have some left over. And that's when, of course, bacterial infections can kill you. That's when you need help, outside help, of course. But when your body produces white blood cells to go and hunt down these bacteria, it also does a few other things to help protect you. One thing, of course, is you get a fever. When you get sick, you have a fever. Many people think that's an awful thing, but actually that is your body trying to fight this bacterial infection. Bacteria and viruses can only survive in a certain temperature zone. So what your body does is it raises its internal temperature to try and kill off these bacteria. So next time you have a fever, your body is actually trying to save you by heating you up, because you can survive a higher temperature, but the bacteria cannot. Isn't that awesome? Another thing that's awesome, actually, is when the white blood cells kill these bacteria or viruses, a few of the white blood cells actually remember that bacteria. So next time you have the same bacterial infection, your body can hunt it down and kill it much faster. Your white blood cells actually remember a type of bacteria. Isn't that awesome? And that's actually how immunology works. If you have a flu shot, or if you have an injection against a certain type of bacterial disease, what that is doing is introducing a small amount of that disease into your body so that your white blood cells can remember that disease. You're basically programming your body to fight diseases. That's absolutely awesome. I mean, I obviously knew that flu vaccines and vaccinations worked, but I didn't know how they worked. That's quite incredible. Our bodies can be programmed. Anyway, antibiotics, they stop bacteria, they kill bacteria. How do they do that? Well, what they actually do is the antibiotic attaches itself to the bacteria and it stops the bacteria building its cell wall. So when the bacteria splits into two, it has to obviously recreate its cell wall, and the antibiotic stops it doing that. So because the bacteria cannot reproduce its cell wall, it dies. It needs its cell wall in the same way you need your skin to stay alive. So bacteria can harm humans, and antibiotics can stop bacteria. So antibiotics are an extremely useful source. Our bodies cannot kill all the bacteria, so we use antibiotics to kill the bacteria that we ourselves cannot kill. Okay? So where did antibiotics come from? Well, how did we discover antibiotics? You probably know the famous story. Alexander Fleming, Friday 28th September 1928, first discovered penicillin. How did he do it? He had a petri dish full of a type of bacteria he left out overnight, and the window was open. And when he came down in the morning, mold from outside had come into the petri dish. And when he looked at the petri dish, he noticed that where the mold was, there was a space between the mold and the bacteria. So something in the mold was actually preventing the bacteria from growing. Now, he needed to know what. So he analyzed it. He did a lot of tests, of course, and he worked out that only one kind of mold, the penicillin mold, worked. So the penicillin mold, something in the penicillin mold, was stopping the bacteria growing. It was inhibiting the bacteria. And obviously he realized the huge ramifications, the huge implications of this. However, Alexander Fleming was a notoriously poor communicator. He was very bad at speaking to people. He was your stereotypical scientist. He was excellent in the lab. He was an amazing chemist, but he was not so good at communicating his ideas. So when he discovered this penicillin, when he discovered the effect penicillin has on bacteria, he tried to tell people, but nobody would listen. Nobody would believe him. Nobody would read his reports. He couldn't get anybody to try and replicate it. He couldn't get anybody to try and produce it. Huge problems. So for a few years, nothing happened. Then, luckily, 1930, a man called Cecil George Payne, he had heard of these experiments, and he tried to use penicillin to cure an eye infection in one adult and two children, and that actually worked. And because of him, news of penicillin started to take off. Then in 1940, a man called Howard Florey and Ernst Boris Chain, they worked out how to mass produce penicillin. And they took this information across to America. Then, of course, what happened? 1941, World War II breaks out. Well, World War II was already going on. 1941, America joins World War II. This is probably the most important date, the most important period in the development of penicillin. Why? Because in a war, most people that die don't die from being shot. They don't die on the battlefield. They die after the battle. They die of war wounds. They die of infections. They die of disease. For example, if you look at the US Civil War, 1861 to 65, for every 3 people that were killed on the battlefield, 5 people later died of disease. Depending on the war, approximately 70% of people, of casualties, are caused by disease, by infection. And what is infection caused by? It's caused by bacteria. How can you stop bacteria? Penicillin. In the beginning of 1941, there was enough penicillin in the world for about 10 people. By the end of the Second World War, June 1945, the American government was producing 646 billion doses of penicillin every year. Thanks to the Second World War, the production of penicillin exploded. And thanks to the Second World War, we now have penicillin for everybody. If the Second World War had not happened, who knows how long it would have taken for penicillin to be developed. People always say war is bad, and of course war is bad, but a lot of good things do always come out of a war. That could be an interesting topic later on. Anyway, 1945, after the Second World War, Fleming, Foley and Chain, they were all given the Nobel Prize for chemistry for the things they did for chemistry. And thanks to them, we have penicillin as we have it today. However, as you may have heard, antibiotics are being used to fight bacteria all over the world, a lot. We take a lot of penicillin every year. We take a lot of antibiotics every year. And it does work, of course. However, bacteria evolve. And this is absolutely amazing. This is proof of evolution. Bacteria evolve to cope with antibiotics. So an antibiotic that used to stop the bacteria growing its cell wall now doesn't work. We have to constantly try and produce different kinds of antibiotics to fight these new and growing bacteria. Who knows, at one point in the future we may have bacteria that we cannot treat, and we have to think of other ways. Nanorobots might be a good way. You send nanorobots in to actually physically kill the bacteria. That's probably not far in the future. There's another topic there, I think, for a talk. So, bacteria evolve. Bacteria reproduce themselves, but occasionally mutations appear, and these mutations make the bacteria stronger to an antibiotic, which of course is an advantage, which means that advantage is then passed on, and the bacteria that are killed by the antibiotic die out, and the bacteria that are resistant to the antibiotic survive and replicate and reproduce. And there you have evolution in a nutshell. A perfect example of evolution. Anyway, so thanks to Alexander Fleming, but possibly more than that, thanks to the Second World War, we have antibiotics as we know them today. However, they are becoming outdated, and soon we will have to think of a new thing. Anyway, thanks for listening. Thanks for watching. I hope you understood this. As I said before, if you click the link down there, you can see the script and you can see questions for this, and you can also see some sample answers. If you liked it, click like. If you want to subscribe, that's somewhere over here. It looks like my face. Please subscribe. Thank you. I'll see you again next week. Have a nice week. Bye.